Hi, everybody. My name is Chris Greco, and welcome to the Data Show. It's all the show all about data, all about how it's used, how it's misused, how it's abused, the situation as to how it affects us, impacts us, and it's something to talk about. So, what are we going to talk about today? This is a 30-minute show, and basically, what we try to do is we try to stay on one topic if at all possible, and we dissect that topic. We dissect that study, the research, the data, and we try to make sense out of exactly what the media is telling us about that research study. So I think that that's pretty important. So what are we going to do today? What are we going to talk about? Well, we're going to talk about this question. If you remember last week, and maybe the week before last, we talked in Data Show, we talked about presenting questions. And then from that question, then you present a hypothesis. From that hypothesis, you try to show if there is a statistical significance to that hypothesis. Is it true or false, but does the data support that hypothesis or does it reject the hypothesis? And that's where a lot of people, they don't understand the truth and falsity of things when it comes down to data aspects. And I think this is important just to take a second and talk about this. When we talk about data proving something, we prove it from a probability and statistics point of view. The truth of a hypothesis is based on data. If that data is somehow skewed or biased, then by virtue of that the results will be biased, and that means that that research itself can be considered to be invalid or valid only for a particular area, particular population, particular sample. So that's where it's really important to talk about these things and figure out exactly what it is that this data shows or doesn't show. Now, there are going to be people that are not going to be happy with this show, this particular episode, because I'm going to talk about I'm I'm going to be talking about this question. Is having a gas stove physically harmful? And I think that's what they're asking, that's what they're trying to get to. And by virtue of that, we're going to take a look at the hypothesis, which is having a gas stove is physically harmful. That's the null hypothesis. The alternate hypothesis is that having a gas stove is not physically harmful. There's been a lot of this in the news within the last week or so. I mean, a lot of it. Talking about asthma, talking about different aspects, talking about this, talking about that, gas stoves, studies, all these different things. So what I'm going to do is, first of all, I'm going to present the study. Okay. So this is the first thing we talk about the study. This is from PSE, Bringing Science to Energy Policy, PSE healthyenergy.org. It is a media. It's a media article measuring air quality impacts of gas stove leaks. Now, this is really, really important when we talk about this. What does the headline say? The headline says measuring air quality impacts of gas stove leaks. Now, does your gas stove leak? Don't know. I have gas detectors in the home. I can tell you that if there is a certain amount of gas in the air, I will get alerted. So, I mean, these are the types of things that you can do to help protect yourself, your family, and your home, is to get these gas detectors. They're really relatively inexpensive. You can get them off Amazon, but the bottom line is all this is, what does this mean? So we go down to the background. Now, in the background, it says in California, 11.5 million households use natural gas. 11.5 million households. All right. So this is interesting because it says in a peer-reviewed study published in Environmental Science Technology, PSC scientists tested natural gas from 159 homes across California. Now we sit back and we say, wow, 159 homes. In California, 11.5 million households use natural gas. Doesn't necessarily mean, it says of these 70% cook with gas stoves or ovens. So 70% of 11.5 million. So 70% of 11.5 million is what, about 7 million, 7 million people. Of that, they tested natural gas from 159 homes across California. across California. So if you take a look at this published in Environmental Science and Technology, which I did, this is what you come up with. You come up with a full study. Now, look, folks, I'm not telling you you need to read this thing like, absolutely, but it is interesting when it talks about these areas. It talks about the Environmental Science Technology article talks about natural gas stoves and 40 plus million U.S. residents release methane, a potent greenhouse gas, through post-meter leaks, and incomplete combustion. All right, so we quantified methane in 53 homes during all phases of stove use. Now, they say here 159 homes across California. Here it says 53 homes. So I don't understand that numerical disparity. Maybe somebody can tell me this. They can contact me through Pod TV. They can contact me through. Contact me through whatever. They can contact me through my email here. You can get it through myself and Ralph Greco. He's the other co-host. He's not here today. So basically, that type of thing. Contact me through my website. Tell me why this is. Tell me why there's a disparity here. Why all of a sudden is there something that is 53 here, 159 here? Now, a lot of people might say, Chris, what is the difference? What's the difference? Well, I'm going to tell you what the difference is. So this is called statistical power. Now, I'm going to go to an add-in here. What they have called real statistics. Now, if you really want to know real statistics, then what you do is I'll show you how to get there. But it's from a website, and basically what this data analysis tool does is it will tell you the statistical power, which is really kind of nice. So if I have a statistical power and sample size, so I know it's a one sample, and I'm going to consider it normal at this point in time, just for that. Now I want to know what my power is going to be. 0.80 is a good power. 0.80 good power. So now we take a look at this and we say, okay, what's my effect size? Now, if you don't understand effect size, you're going to sit back and go, I don't understand what that means. So let me tell you this one. 0.2, 0.3 is a good effect size. 0.2, 0.3 is a good effect size. So we're going to pick 0.3. What's my sample size here? Sample size is 53. Remember, because that's what they said in the study. The number of tails is going to be 1 because we want to know if there is or if there's not. So it's going to be a one-tail test. And my alpha is 0.05. Just trust me. These are all pretty normal aspects. Now, if I take a look at this and I say 52 is 53. Say 53. I'm going to have a 0.70 power. That's not a good enough power. You want 0.8. 0.8. Well, if they had 159 out of that sample size, then guess what? Now your power is almost 1. Your power is way, way up there, your statistical power. This is to test your type 2 error. And, I can go into that type of area, but I don't know if I really want to do this on a show that just talks about general data stuff. But that's the difference. If you have 159 sample or 53 sample, that makes a heck of a difference. Now, if I want to put this down to a 0.2 effect size, I get down to 0.8. But if I have 0.2 size, so in other words, as I'm going down, the power goes up. The effect size is different. It's not like, if I use, people use correlation. Like if I have a 0.80 correlation, well, effect size is different from that. Effect size is Cohen's D. It's that type of thing. So it's the smaller you get, the better the effect size, the better the correlation. So basically what happens is if I say 53 here, and now I'm at 0.42, which is abysmal for statistical power. So that's why whenever we go through this stuff, we have to go through it and sit back and say, okay, 159 versus 53, that's a heck of a difference from the standpoint of sampling aspects. So, and where did they get 53? So they're saying, well, you take 53 and then talks about 32 homes. It did that. And then you have different aspects using a 20-year time frame for methane. Annual methane emissions from all gas stoves in U.S. homes have a climate impact comparable to annual carbon dioxide emissions of 500,000 cars. Yeah, okay. So that's, they're trying to compare that, which is good. I mean, that's good for them that they're trying to do that. So this is basically what's going on here. Now, they mention here an R squared. So what is, what's an R squared of 0.76? In 32 homes, we measured basically noxious gases, NO, nitrous oxide, nitrous oxide, nitrous dioxide emissions found to be linearly related to the amount of natural gas burned. So the natural gas burned and the release of these emissions has an R squared of 0.76. Now, again, we sit back and we say, okay, what's an R squared of 0.76? So here's what, when we talk about R, we talk about a thing called correlation. So correlation is something that as we talk about that, correlation increases. So if you have a correlation, let's say a good correlation, right? A good correlation would be in my statistical opinion. After decades of teaching statistics and looking at data and looking at research studies and doing data aspects for federal government, for civilian, for all these things, a good solid correlation is 0.70 and above. Now, people will dispute that. They'll say, oh, no, good, 0.30, 0.70 and above. Now, a correlation is basically what they call R. That's a correlation. R squared is literally taking that R and squaring it. That's all it is. So basically, if you have an R squared of 0.76, right? So the thing you want to do is if I take the square root, right? If I take the square root of this, I have 0.87. 0.87, now that's R squared. R squared, and this is R. Ladies and gentlemen, that is a really, really very potent correlation. 0.87 is very good correlation. An R squared helps to it's an anti-biasing type of exercise. So basically, when you have an R squared of 0.76, that means you have an R of a very high nature. So that's in other words, what I'm saying is that 0.76 is a really, really positive correlation. And that, again, 32 homes. Again, now we're even bringing that sample down even further with 32. We started 53, we're now down 32. So 32 homes out of those 53, which is basically a little above half, had these situations that linearly correlated, linearly related, right? So that's what we have here. What I wanted to show you was that I mean, this is a really good study. It talks about different aspects. No U.S. based indoor exposure guidelines or standards. Got it. They uh, they talk about these different aspects. They talk about materials and methods, which is great. Site selection. 53 again with 53 homes in 7 California counties. 7 California counties. Okay, they say all across Canada. So what does that mean? Well, let's take a look at this for a second. Number of counties in California. I want to know how many counties there are in California. List of counties, Wikipedia, and I don't really want anything Wikipedia. So counties.org, California counties. So here is California census.gov. So let me go to census because I do like that area. So sometimes I'll have counties. There are 58 counties in California, right there. Census.gov says there are 58 counties in California. How many were sampled? 7. 7 out of 58. 7 out of 58. 7 out of 58. So a lot of people might say, okay, Chris, what are you getting at? All right, well, you know, let's just take in here. So we're going to lose it. Okay. So we're going to go to calculator real quick. And we're going to say, we're just going to do this. So we're going to say 7 out of 58. So basically 12%. 12%. That's it. 12% of the counties. And how many in each county? How many did they do? So we're talking about, I mean, it says between January and May 2021. Now they do have a table here, which is good. So we'll take a look at the table and we'll take a look at see what we have here. This thing I wanted to show you is this one right here. This is the experimental setup. All right, now folks, I want to point out a couple of things to you. First of all, here's a fan. I don't know what that fan is for other than just, I guess, circulating air. There's no range hood here. There's no range hood, and there's a piece of plastic. Now, look, I can be flippant about this, and I can say, because every kitchen has a piece of plastic, going from ceiling to floor to cordon off the area right beside the gas stove. Folks, it doesn't work like that. My gas stove has an open kitchen. That open kitchen has a range hood. Also, I have ceiling fans. Also, I have recirculating air. So, I mean, it's that type of area where we talk about, okay, experimental setup. But the thing is, and very, very important, is that this situation was set up, and they show it to you. They show it to you. See, the stove does not have a range hood. Typical experimental setup. The plastic in the background is used to partition the kitchen. Fans circulate the air in the space, but it's still recirculated air in that space. It doesn't go outside that space. Connected to the pole in the center of the room is an inlet hose which transports air to the analyzers in a separate room, monitored by researchers outside the kitchen during measurements. So, I mean, this is, and they talk about decay. This is literally what they call the decay formula right here. It's a pretty standard formula. It talks about, I mean, you do it for decaying of radioactive material, you do it for different aspects. I saw it as like, oh, this is good. So they do, I mean, they use all the things that you need to use to be able to make that work. And their visualizations are fantastic. I mean, they really do, comparison of roof measurements, different aspects. They even talk about the different counties, all these different areas. So they're very, very transparent about what they do, how that is, right? um, and how these work. So Santa Clara, no Knox, no oven, no broil, and then talks about the different brands. So I mean, all these different brands, different areas, things like that. So they did try to make all these different areas as complete as possible. The thing that I would love to see is, I would love to see, if at all possible, um, the limitations on this. So I think any good solid uh, study does point out limitations. So what we'll do is we'll take a look at this and see if there's any material and methods, sampling overview, which is good, general sampling scheme. I mean, just exactly what they did. Well, I mean, it really a very, very good study from that standpoint. The only thing that I have a problem with is the sampling, uh, and the length of sampling, and it's only one state. It's only California. One state, 7 out of 58 counties. It just didn't. I mean, so I didn't really. I appreciate what they did. I appreciate all these areas. And I'm going to tell you right now, the study people don't have any idea that this study somehow is going to make these gigantic media, blastings. But that's exactly what happens, because when you take a look at this, you take a look and say, okay, what is it that they're trying to do? What is it that they're trying to prove? The idea is that the study, and just again to point out, this is the title of the study: methane and NOx emissions from natural gas stoves, cooktops, and ovens in residential homes. So this is what they have, right? This is what they have. So it's very, very important to understand that this is the situation that they're taking a look at. So I have no problem at all with the researchers, with the study the way it was, with whatever else happened. I'm good. From the standpoint, I think the data they had is limited. I think the sampling they had is limited. I think their study was done in an outstanding manner. The data that they got, they they documented well. They had all these different things that they took a look at and were able to make it work for them. And I appreciate that. I really do. But the bottom line is this: is that based on this study and this study alone, are we willing to make jump to conclusions? Is having a gas stove physically harmful? Is that has that actually been proven? Has the situation been done so that it's been proven as harmful? Well, based on their environmental aspects and whatever else they had, um, they say that there is correlation between the gas being on and the noxious gases that come out. The methane and all that. So it's that type of thing that when we take a look at that, we take a look at, they talk about cumulative methane emissions and all these things. So I would say that, they talk also about previous studies, which is good because I think that's very important. And they even point out study limitations. So to improve future home appliance emissions research, we provide the following recommendations, and they present 4 good solid recommendations, right? And all these recommendations, because of sampling limitations from COVID-19, we were limited in where and how we could sample homes and could not include a representative selection of low-income multifamily homes. Future work should emphasize measurements within this demographic. They themselves point out the limitations of the sampling. They point out the limitations of the sampling. So I think that that's important. And folks, studies are never put out to fool people. Studies are put out to try to inform people. And I think that this is, and not to point fingers, but I'm going to point a finger. The media are the ones that make these studies as if that they are the absolute truth. And folks, they are not. Let me point this out very succinctly. They are not. Now, people will sit there and say, well, Chris, what about the samplings that have 22,000 people or 21,000 people? Most of the time, if not all the time, those samples, those 21,000 people are taking from a database that's either government or county or whatever it is. And that means that they rely on data that's inputted into that database that you hope is valid. You hope is verifiable. So all those things go along with that. So I think that this is something we need to take seriously, and we need to understand that yes, there are probably things in our home that are dangerous to us. There are, especially in gas homes. That means you have to have proper gas regulation. That means you have to have proper gas checks. That means, if you smell anything that smells like gas, which is it's usually odorless, but they put in an odor so that you can smell gas, any gas leaks, that you call your gas company and have them come out. Put gas detectors in your home. They're not that expensive. You plug them in, and you set them up, you plug them in, set them up, and then what happens is that is when you can take a look at them and take a look and make sure that you're not having any gas leaks. I am in a natural gas home. I am, so I have to really be careful about that. And the way that the the way we're trying to do that is to make sure we vent, is to make sure that we have recirculated air, which we do. We have 2 main fans, one on the bottom floor and one on the top floor, that constantly recirculate air. So I think that's important. We have ceiling fans that we use. So all these things are very, very important, and they're part of the safety aspects. So taken from this, I would say this study, well done study, but limited from sampling. It's only one state. It's only 7 out of 58 counties, and it's only 53 households. Even though the article said 159, I did not read anywhere of 159 in this study. Now, I may have misread it. I may have not read it close enough, but all I saw was 53. So that's where you have to take a look at these media reports and go to the study. Most of the time they'll refer it, which I give them a lot of credit for. They'll refer to study. Go to the study. Just read what you can read about it and try to learn as much as you can. And that's what the data show is for. So on that note, I'm going to say farewell from the data show. Thank you so much for tuning in, and you know continue to take a look at data studies and make sure that those data studies really reflect what the media has put out, and don't be persuaded either way from just one data study. Take a look at that. Ask people about it. Ask me about it. Send me a study. I've given you the email addresses at the end of the show. Tell me if there's a study that you want on the show, we'll dissect it for you. We'll tell you about it. We'll try to bring the truth out, the validity of the study and how it all works and how you can read it and what you can do with it. I'm writing a book right now. It's going to be released within probably the next 2 months, and it talks about studies that were done that you're going to take a look at and you're going to laugh, and I hope you do. Even an example of a template that's put out that where you can do your own study on whatever you want to do, and look at data and look at different aspects. So on that note, thank you very much for watching. And please, when you see anything having to do with research study in the media, try to track that down. Take the time, track that down, or send an email to me, and I'll track it down for you. Thanks. Have a great week, and take care of yourself and stay healthy. And oh, by the way, if you have natural gas in your home, get some gas detectors. Take care.